once stated, "It is not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is most adaptable to change." All of you have taken at least 1 year of biology in high school, where I'm sure you learned about evolution. Today, I hope to teach you something new about a certain type of evolution. This speech will focus on the convergent evolution of crabs, which is a very popular subject in the field of convergent evolution. There's even a name for this process, and it's called carcinization. Convergent evolution happens in many different species, but the carcinization of crabs is a special and unique type of evolution. So, according to Eric Bianca, an evolutionary ecologist working at the University of Texas, quote, "Convergent evolution is the process by which unrelated or distantly related organisms evolve similar body forms, coloration, organs, and adaptations," end quote. Mimicry is when a species will evolve to look similar to a species that already exists. The original species is usually poisonous, which is a benefit for the mimic because they don't get eaten as much. And so too much predators will cause, or too many mimics will be bad for the original species because the predators will get used to eating the mimics and not be afraid of the poisonous ones. So there are many examples of convergent evolution, including the viceroy butterfly and monarch butterfly, the eastern coral snake and scarlet king snake, and many different types of flies which have evolved to look like bees. So usually this type of change happens because the two species are in similar ecological climates and have to deal with similar problems. In order to discuss the convergent evolution of crabs, it's important to know their anatomy and what the exact definition of a crab is. So there are two different definitions that most people have for crabs, as stated in the article "Evolution of Crabs, History and Deconstruction of a Prime Example of Convergence" by Gerhard Schultz, a prominent German biologist. One characterization is the certain body shape of crabs, which you all know with just their body shape, 10 legs. While the other references the supposedly true crabs with the name of Brachyura. So in the article "Hermit to King or Hermit to All, Multiple Transitions to Crab-like Form from Hermit Crab Ancestors," which was published by Oxford University, a crab is characterized by a widened carapace and a pleon, which is shorter from being folded flat under the body. So a carapace is just the hard outer shell of the crab, while the pleon is the abdomen of the crab in red, as you can see here. In crabs and lobsters, the pleon is backwards, which is why their body is longer. So in this speech, I will normally say the name of the article instead of the actual authors because it's a long list of authors for most of the articles. So in the joint paper, "Mitochondrial Gene Rearrangements Confirm the Parallel Evolution of the Crab-like Form," there are three major groups of crabs, which live in areas such as abyssal trenches, open sea, freshwater, and even on land. They have also been around for over 320 million years. As you may recall earlier, I said mimicry will usually happen when creatures are in similar environments, but crabs are interesting because they still adapt to evolve to this form while being in all of those different environments. So it's very interesting. So now that you know about convergent evolution and what defines a crab, let's move on to carcinization. So in the Biological Journal of the Linnean Society, Jonas Keeler, Kristen Rinkler, and Stefan Richter give some of the history of carcinization. The process was named by English zoologist Lancelot Alexander Bourdelle in 1916. The group where carcinization happens is the sister of the Brachyura, which, as you remember, is the true crabs, and it's called the Anomura. Quote, "Bourdelle used the term carcinization not only to describe the evolution of the crab-like habitus in Brachyura, but also to refer to the repeated formation of a general habit of body of a crab in the evolutionary lineages of Anomura, which resemble true crabs." So that's basically saying that they converge on the same kind of body shape. That's end quote. The form of the crab has evolved independently different times with the anomurans, which is very impressive when you stop and think about it. To have the same type of body shape in all of the species is almost unheard of in the field of nature. So to the left here is a Brachyura, and to the right is an Anomura, which most people would not be able to distinguish on their own. To see a prime example of carcinization, we can just look at hermit crabs and king crabs. Two of my sources were written about these two crabs alone. So many of you have probably seen these two types of crabs, and you may find it strange that they are closely related. One little pet crab that lives in shells and a crab with a dinner plate sized body and 2-foot-long legs are related to each other. So in the article Evolution of King Crabs from Hermit Crab Ancestors, a publication by Yale University, it stated that hermit crabs have been living in shells for over 150 million years. King crabs descended from hermit crabs, and the process of carcinization took only 13 to 25 million years to complete. It's also interesting to note that there are also crabs who live in both shells and grow a carapace. The coconut crab lives inside shells for its juvenile years, and then it grows a hard shell around its body once it reaches adulthood. So the group of biologists who wrote mitochondrial gene rearrangements confirm the parallel evolution of the crab-like form state, and I quote, "Interestingly, although transitions to the crab-like form have happened repeatedly, there is no case in which members of a crab-like group have reverted back to a shrimp or lobster-like form. This suggests that the evolution of the crab form may be irreversible," end quote. There are a few hypotheses on why this would happen, such as a crab-like form possessing a large advantage on other species, or that there's a common developmental mechanism which leads to its evolution. So, in this speech, I've informed you all on the mind-boggling convergent evolution of crabs from non-crab-like forms, along with some other examples of convergent evolution. All in all, I hope you learned something about the evolution of crabs and convergent evolution. You'll probably never have to know anything about carcinization in your life, but it's still very interesting. Thank you.